So now let's look at RCTs in practice. We saw already how to randomize an RCT, how to stratify if we wanted to balance certain covariates. But now imagine that we already run our experiment. How do we analyze that data? It is super easy, okay? With randomized controlled trials, there's really not that much difficulty and you can be very straightforward, okay? So statistically speaking, there's not much complications when you're trying to work with data from an experiment. The first thing you should do, as we did before, is check for balance, okay? So you first want to know if the randomization was done correctly, meaning, again, always look for how many unbalanced covariates you have, see whether that generates sort of a pattern or not, whether that unbalanced covariate is something that you think is relevant and it's imbalanced, because even though it's that difference is just random, it might still affect your result in that sense, okay? So you would need to take that into account. And the second thing is, after you check for balance and you think that everything is looking okay, you just calculate the difference in the sample means between the treatment and the control group. Easy as that. So the difference between the samples, you can do it either like literally running just a t-test on STA, in R, or you can also just run a simple regression, just like that. Outcome regressed on the treatment assignment, and that should give you your estimate of the treatment effect. Easy peasy. So now let's look at some data. So we're going to be talking about this very large-scale mobilization experiment of Get Out the Vote that was done in 2006 by Arsenault, Gerber, and Green. This was a huge experiment, actually, where households were randomized into a treatment assignment or not. And basically, they contacted with Get Out the Vote phone calls to those households that were assigned to treatment, okay? So if a household had 1 or 2 registered voters, they were randomly assigned to their treatment and the control group. They assigned more to the treatment group, to the control group, because of course calling might be more expensive, so you only have limited number of phone calls that you can make. And for those that were treated, they tried to call them and just pass a get out the vote sort of message, so to incentivize them to vote in the 2002 election. Okay. This was actually a stratified RCT. So they had 2 states, Iowa and Michigan, and they have different districts in there. Some districts were deemed competitive, some districts were deemed not competitive. Okay, so that also might, you might think that might drive different results. Okay, if a state is competitive, usually it drives up voting, while if a state it's not that or a district is not that competitive, you might think that the effect of get out the vote might be smaller. Okay, or maybe the other way around. But clearly, if there's a heterogeneous effect, you might want to have those key covariates, such as state and the competitiveness of the district. You want to have them balanced. Okay, great. So let's go to R in this case. Okay, great. So I'm just gonna erase all this to make it easier. We're not gonna need this, so that's fine. So now I already have the data loaded, basically because it takes a little bit to actually load. You will see that in your when you run the script, but this data is called D. Okay. So if you see here, I'm in the first 6 observations of this data frame. We have a variable that's called persons, which is basically how many registered voters are in each household. Remember that it could be 2 or 1. We have the variable competitive in this case, which is basically 1 if the district is competitive and 0 if not. We have a vote, basically if the person voted or not. if the person voted or not in the 2000 election, if the person voted or not in the 98 election, whether the person is a new voter, age of the person. This is the outcome, whether they voted on O2 or not. This is the actual treatment, and this is going to be important. This is whether the person could be contacted or not. This is the treatment assignment, okay, treatment real. And don't worry about this one. This is the state. It will be 1, I think, for Iowa and 2 for Michigan. Doesn't really matter. This is whether the person is female or not, and whether the gender is missing. Okay, so it's important a lot of the times if you can get some covariate to have a dummy that shows whether there's a missingness or not. Okay, so what we want to do basically is see whether this is balanced. Okay, one important thing, however, is that the balance in a stratified RCT is checked by strata, in this case, by stratum. So this is what we're gonna do now. So the first thing we're gonna do is generate a new balance table, just because we're gonna take out anyone that didn't have a phone that was listed. Okay, it doesn't really matter a lot in the sense of what we're doing, but this is like real data from an experiment. So basically they randomized houses, and some of them did not have publicly listed phones, so they couldn't contact them. So basically they kind of like dropped out of this thing. So that's why we're not going to consider those units. So I'm going to take them out of the sample. So I'm going to generate a new data frame. That's the one that I'm going to work with now. That's going to be a DS1. And I'm just going to drop those unlisted those household that has unlisted phone numbers. So this is the data that I'm going to work with now. And now what I want to do basically is see whether this is balanced by strata or not. Okay, remember that we have basically 4 stratums. We have 2 4 strata. We have 2 states, and we have 2 values of competitiveness. So basically the combination, we have 4. Okay, so for each of these 4 stratums, we have treatment and control. So we basically want something that kind of looks like an 8-column table, right? So the first thing we're gonna do is actually work with the tidyverse to try to generate sort of this table and then rearrange it to make it look prettier. Okay. So we're gonna start with this table. I'm just gonna call it tab, and I'm gonna pass first our data. Okay. I'll pass our data, and then I'm gonna say please group it by. I always say please group it by. I'm very polite towards R. And I'm gonna group by the different variables that comprise the strata, okay, and also the treatment assignment. Basically, because again, we want 8 columns, okay, for each state, for each competitiveness, for each value of the treatment, basically. So this is gonna take this data and it's gonna group it by state, competitiveness, and treatment status. Okay, so this is basically a combination of 8. We have 3 variables, each one has 2 categories. That's 8 combinations. Great. But then we want to basically tell them what we want to see. So in this case, let me take it. There's things in our data that I actually don't want to include in our balance table because it doesn't make sense. So for instance, I don't want to include the outcome in our table, right? Because it doesn't, like, I cannot say whether the outcome is balanced or not, right? It doesn't really make sense. We're, again, checking balance for the covariates. The outcome is not a covariate. So what I'm going to do is basically say select and select everything but the outcome in this case. And I'm also going to leave out this treat pseudo. which it doesn't really matter for this exercise. But I'm just going to exclude those two basically because those two are not considered covariates in this case. Okay, so by the way, I don't think I have the tidyverse loaded, so let me just load it. Great, and then what I'm going to do is, now that I've told it, take my data, group it by state, competitiveness, and treatment status. Please drop the outcome and that other variable that I don't care about. And now I want you to summarize all the other variables and give me back the mean. Okay, so basically, again, take all the other variables that are left. So persons, new registrant, age, contact, etc. And sorry, I'm gonna take out contact too because that's the actual treatment. I don't want it there. And all the other variables, just summarize it and give me the mean, again, by state, competitiveness, and treatment. Great, let's run this. Okay, this is usually, you might have this problem if you have two packages loaded that use the same variable, the same function. Okay, so in this case, this is a teachable moment. If you do select, as you can see here, there's actually two packages that use the function select, right? DP LYR, and also ridge regression, which I had loaded because I was running other things before. So basically what happens is that they take different arguments. So R doesn't know which one to use, whether the one for the mass package or for DPLYR. So I basically just have to say take select from this package. Okay, so now again we run it. Awesome, no error. So let's see what we got. So as you can see here, we basically got a column for each variable. So these first three are the ones that were grouped by, right? So again, we have 8 combinations: state 0, 0, 0, 0, 1, 1, 1, 1, competitive 1, 1, 2, 2, 1, 1, 2, 2, and 0, 1, 0, 1, 0, 1. Okay. So basically, each of these rows represent one treatment assignment within one strata. So this basically represents the control group on the on a competitive state, on a non-competitive state within state 0, which let's say it's Iowa. Okay. And basically, this shows that the average is 1.5 people. 56% voted on 2000. Average age is 52. If you look within the same stratum, state 0, competitiveness 1, but for the treatment group in this case, you can see that the percentage that voted on O0 is very similar to the control group within this stratum. The percentage that voted on 98 is also very similar within this stratum. The percentage of new registrants are also very similar. So you can see that it's very balanced, okay? And the same thing is if we take this next to 2 rows, again, which is state 0, let's say it's Iowa, in a competitive district between the treatment and the control group, you can see that this is very well balanced, okay? But again, what we want is more like the mean top sort of idea. So we want kind of to flip this, right? So we want to transpose it. So what I'm going to do first is save the names of the columns, okay, of tab. So as you can see, I just saved the names because then when I flip it, I want it to be the row names. And then what I'm going to do is generate a new tab. I'm going to rewrite the same tab, okay? Or let's say tab 2. And I'm going to transpose it. That's T. T is transpose of a matrix. And I'm gonna actually round it because I think that there's too many digits here. Okay, so let's say 3 digits. And then I'm gonna say that the row names for tab 2 are gonna be what were the call names from tab. Okay, great. So let's run those two. And as you can see, tab 2, great. Now I have this, and I have persons, and again, these first two are stratum, these other two are stratum, these other two are stratum, these other two are stratum. Great. So now let's just do one bit more. This is just, again, aesthetics. I also write away in the R code of how to do this with Reactable, which is a bit more complicated, I think, but it generates really pretty tables that are interactive. So some of you might want to be into that. But if you're not, you can actually manually kind of like clean this a little bit. So again, we're going to do tab 2, and we basically just we want to drop the first two, we want to drop the first 3 rows, okay? So we're going to go from row 4 to the number of rows of tab 2 and keep those. And then for call names of tab 2, again, this is very manual. It can be kind of boring, but I think it's important for you to know kind of how to do this. So I'm gonna say that the first is stratum 1, control, stratum 1, treatment, stratum 2, control, stratum 2, treatment. And I can do the same thing, but just say stratum 3, stratum 3, stratum 4, stratum 4. Great. And just run that too. This is not exactly the same way that I have it on the code, but you can check it out. So again, so basically this is how you get kind of like a cute little table. It's manually made. It's not very efficient a lot of the times, but this is how you can get it. Okay, so basically, again, we have each row is a covariate. Each column in this case is a treatment or a control group within a strata. So basically, this two are for strata 1, this 2 are for strata 2, strata 3, strata 4. And you have the treatment and the control group. And you can see that they're quite balanced. So even though, for instance, this strata 3 seems to have way higher values in age than, for instance, stratum 2, it doesn't really matter because they're balanced within each other, between each other. Okay? So great. That's awesome. Now let's go back to the slides. Great. So now we checked for balance. We can see that everything is cool. As you can see, this is basically what we got from the reactables. It's the same table that we have, just formatted differently. The cool thing is that you can sort of like move this around, highlight it, but it doesn't really matter that much. But as you can see, basically this is balance. Since our randomization worked. Awesome. One important thing here, if you can see, I did not leave contact out in this case, which is actually not a covariate, so I should have. So be careful with that. And we're going to talk about that variable though. Okay. So now we need to estimate the effect. Okay. So depending on the design, as I mentioned before, usually we can just compare group means or fit a simple regression. So a lot of the times, if you're just thinking that you have a regular RCT where you randomize people just without stratifying or without any other complexity in the design, you can literally just estimate the difference. So take the treatment group, estimate an average, take the control group, estimate an average, and then subtract those. Okay, that's totally fine. That will give you the correct point estimate. The problem with this is that with just doing a difference in samples, in sample average, you can't get a standard error, so you will need to work a little bit for that. You can, again, apply a formula for standard errors. You can run a t-test, or you can just run a simple regression. And again, when I say simple regression, it means just the outcome on the treatment assignment. So in this case, I regress outcome, which is voted on 2002, on the treatment assignment, which was the variable treatment real, right? However, here we don't have a traditional sort of simple RCT design. We have it stratified. So because we have it stratified, there's something else that we need to do, which is incorporate a fixed effect by strata. That basically means that I need a dummy for each of the stratums, of the strata. Okay, I'm sorry if this is confusing with stratum and strata, but basically I need a dummy variable for each of these categories, okay? And this is contained here on this gamma sub s. This will be 1, for instance, for stratum 1, 0 for all the others, and then I'm going to have another variable that is going to be 0 for everything except stratum 2, and so forth, okay? And I need to leave one stratum out, of course. We saw that about collinearity. Great, so how do we do this in practice? Again, we're gonna use the estimate R package, so we can run robust standard errors. Remember that it's always better to be cautious on that side. Homoscedasticity is very strange. Usually, you should always assume that you have heteroscedasticity. You should always try to run robust standard errors, okay? So first, we want to create the variable strata. And for that, I just use the variable, the function interaction, and just give it, pass it the variable state and the variable competitiveness. And what this does basically is just generate all the combinations. And it's actually a factor variable, which is great because when I incorporate a factor variable into a linear regression, it considers it like different dummies, okay? So that's basically what happens. So again, I run the robust linear regression of vote 02, which whether they voted on 2002 or not, on the treatment assignment plus the strata variable. Remember that strata, again, is a factor variable, so it will generate a dummy. Okay, this cannot be a numeric variable because if not, it will consider it as a continuous variable, okay, which is not correct. That's not including fixed effects. Great, so basically what it does, it calls this formula, and here it gives me the point estimate. So as you can see, this is the point estimate, is it increased treatment, it increased voting in 0.1%. The probability of voting in 0.1%. But as you can see, the t-stat is very low, which means that the p-value is quite high. So it's not statistically significant at conventional levels. And as you can see, here is the each dummy for the different strata. We don't really need to interpret these, but basically what this does is shift the intercept of the regression for each of these strata. So again, here we can see that we have a pretty nice, precisely estimated kind of, well, I don't know, precisely estimated, but we clearly have a 0, right? So there doesn't seem to be an effect of the treatment assignment on whether the person voted or not. So get out the vote phone calls don't seem to actually work that much. One important thing to note, however, is that a lot of the times treatment assignment is actually different from treatment take-up. Treatment take-up in this case is contact, whether they were able to contact someone in the household or not. So again, you can assign the treatment, so you can call that house, right? Call different households, but you cannot necessarily randomize whether they're going to pick up or not. You cannot control that. That's outside the control. So you can randomize the assignment to treatment, but you cannot usually force someone to take up the treatment. And the difference between treatment assignment and treatment take-up usually generates this this kind of problem, because we're actually not able to estimate an appropriate treatment effect. We can only get what is called an intention to treat. So I intended to treat you, but I couldn't force you, right? So this is the effect of me, my intention to treat, and not necessarily the treatment itself. Okay. Does it affect the internal validity of the study? This is important. It actually doesn't if we take, again, treatment, the treatment assignment as the variable that we're using for the causal effect. Okay. Again, we're not able to estimate an actual average treatment effect in this case, because not everyone took up the treatment. Not everyone was contacted. But we are able to estimate accurately and unbiasedly the intention to treat. Okay, so in that sense, it does not affect the internal validity of the study. If I was using contact, however, in my regression, then it could have affected the internal validity of the study, because who picks up the phone, that actually is not random. I randomized the treatment assignment, but not who picks up the phone. Okay, so there could be confounding there, and you should think about what kind of confounding is probably there.